What if I threw you into space? Not with a rocket. Not with a spaceship. But at the speed of light? No protection. No fuel limits. No aging. You move in a perfectly straight line. How far would you travel? Before you reach the end? Would you hit a wall? Would you loop back around? Or would you keep going, forever? Tonight, we're not just asking how big the universe is. We're asking whether it even has an edge. In 2016, astronomers made a discovery that pushed our understanding of the universe to its limits. They detected a galaxy known as GNZ11. The light we see from it today began its journey 13.4 billion years ago. That means when this light left the galaxy, the universe itself was only a few 100 million years old. We are not seeing GNZ11 as it is now. We are seeing it as it was near the very beginning of time. It's like holding a camera that can photograph the infant universe. A moment frozen from a cosmos that had barely begun to form stars. But here's where things become difficult to imagine. You might think that if its light traveled for 13.4 billion years, then the galaxy must be 13.4 billion light years away. But that's not how the universe works. While the light was traveling toward us, space itself was expanding. The universe didn't stay still. It stretched. And it kept stretching for billions of years. Galaxies drifted farther apart, carried by the expansion of space itself. Today, GNZ11 is estimated to be about 32 billion light years away from Earth. Not because light moved faster than it should, but because the fabric of space expanded beneath it. So when we look deep into the cosmos, we are not just looking far away. We are looking back in time. And the deeper we look, the younger the universe becomes. Now imagine you continue traveling outward. You pass the moon in just over a second. The sun in 8 minutes. The outer planets fade behind you within hours. Within a few years, even the nearest stars disappear into darkness. After 100,000 years, you finally cross the entire Milky Way galaxy. 100,000 years of uninterrupted light-speed travel. Just to leave our home. And yet, the Milky Way is only one galaxy among hundreds of billions. You keep going. After a few million years, you drift beyond the local group. The Andromeda galaxy becomes a faint blur behind you. After tens of millions of years, you pass through vast galaxy clusters. Cities of galaxies bound together by gravity. After hundreds of millions of years, you move across enormous superclusters that form a cosmic web stretching across space. Filaments of galaxies, separated by immense voids, forming patterns on scales almost impossible to comprehend. And still, space continues. Eventually, after roughly 45 billion years of travel, you reach what we call the edge of the observable universe. 45 billion light years. That number alone is almost meaningless to the human mind. Yet that is the distance to the farthest light we can currently detect. But here is the crucial distinction. This is not the edge of the universe itself. It is only the edge of what light has had time to show us. The universe is about 13.8 billion years old. So how can the observable radius be 45 billion light years? Because during all that time, space has been expanding. While light was traveling, the fabric of space stretched. Galaxies were carried farther and farther away. Some regions of space are now receding from us, faster than light can ever travel back. Not because they are breaking the laws of physics, but because space itself is expanding. Anything beyond that horizon is permanently unreachable. No signal from there will ever arrive, no matter how long we wait. Now the question becomes deeper. Does space end beyond that boundary? Or does it continue infinitely? If the universe curves back on itself, like the surface of a sphere in 3 dimensions, then traveling far enough in one direction might eventually bring you back to your starting point. You wouldn't hit a wall. You would complete a cosmic loop. But if space is flat, and current measurements suggest it is extremely close to flat, then it may extend forever. And if it extends forever, Then mathematics forces a strange conclusion. In an infinite universe, every possible arrangement of matter must eventually repeat. Given enough space, atoms will rearrange into the same patterns again. That means somewhere, at a distance so vast it defies imagination, there could be another Earth, another solar system, another Milky Way. Not just similar, identical. The same atoms arranged in the same way. The same thoughts forming in the same brain. The same version of you, sitting in a room, watching this exact moment unfold. And not just one copy. Infinitely many. Somewhere, a version of you made a different choice today. Somewhere else, another version made the same one. In an infinite cosmos, identity becomes a statistical inevitability. But here is the grounding truth. Even if there are infinite versions of you across infinite space, only this one is aware of this moment. Only this one controls what happens next. The universe may be finite. It may be infinite. It may be far larger than anything we will ever observe. But your decisions exist here, in this tiny fragment of space-time. And perhaps the most astonishing fact about the universe is not how big it is, but that a small cluster of atoms can look up at it and ask how big it might be.